All right, so here's some help for homework 3. I'll start with question 10. So plan is to go over questions 10, 17, 19, 29, 31, 32, 33. So let's see. Yes, that one, entire screen. Oh, good. Hey, it's working. All right, well, let's go back. Which one is it again? 10? Yeah, 10. 8, 9, 10. Okay, so for question 10, what I want you to do is to be able to interpret a phylogenetic tree that you are going to construct by using this the instructions that I provided you in here. So I just took some population data that I found, and I wanted you to see how you can retrieve that. On the exam, I'm not going to make you do all these steps. I'm going to give you the sequences that you are supposed to compare. Actually, I think you did this in exam 2. So what I want mostly for exam 3 is for you to be able to interpret phylogenetic trees. All right, so we're going to go to NCBI Entree. And then I said, click on Entree, so it's over here. And I said, click on population set. So I just do a find pop set because, you know, it's the fastest way. And then once I'm here, I said, I want you to search this thing. So I'm just going to copy all that. So that's the set that I want you to run some analysis on. Search. Okay, so there you go. So these are the population information that I want you to compare. And instead of like clicking on each of these separately, you just click here on FASTA. It's going to have those sequences there. So we're going to compare these. So we're going to do an alignment. And since we are aligning many sequences, so more than 2, then we're not going to use BLAST2. We're going to do a multiple sequence alignment. Plus BLAST2 would do local alignment. And when we want to do phylogenetics, we do global alignments. So, and I said use specifically muscle because I guess when I did the cluster, it came up with different a different tree, and then the answers wouldn't make sense. All right, so I'm going to paste the sequences I just copied, and I don't have to change anything else here, and run. So let's see. I think this runs fast, but whenever I'm running something slowly, I wanted to share a picture of a boat with you guys. Did you guys see the boat that got stuck in the Suez Canal? It's pretty interesting. Okay, so for this question, I want you to assess or to interpret the phylogenetic tree. So click on phylogenetic tree. And I said, click on the wheel. And the reason for that is because when you do a cladogram, these guys are all aligned and they are, so these trees, they all end at the same spot. And as you know from lecture, the cladogram is showing relationships between these different entities we are comparing, but the length of the branch does not convey information. And that's actually one of the choices. So I wanted to say that that's not true. I think, let's see, what am I saying on that? I'm saying the lengths of the cladogram are proportional to the divergence. So when I'm saying the length is proportional, I'm saying that the length is carrying some information. So like a longer branch would mean that they are more different, and a shorter branch that they are less different. But in a cladogram, that's not true. So do not mark that. And you would know that even without running this. So that's, I'm testing you. Do you know the difference between a cladogram and an additive tree? So here they don't call it additive, they call it real. So we're going to click on that. And now you see like, Meh? So sometimes it's kind of hard to see these guys because it's so tight. So the cladogram helps you with like this with this, and that guy is closely related to that. So these two are closely related to each other. Oh, these, no, the bottom ones. These two, okay, my mouse is playing tricks on me. Let's use a different mouse. Okay, so these two are more closely related to each other, and then this one branches in. So the way you interpret phylogenetic trees, you look at the nodes, and then you start going like further and further from the labels of your entities. Okay, so let's look at the real tree. And these guys, the length might be difficult to see, but this is a little longer than that. And there's some information here that corroborates that. And so the branching pattern is still the same as the cladogram. The difference is that the lengths, they do carry meaning. So these two are the most closely related, as they're like sticking closer to the labels. And this guy is the most closely related to these two because he comes out on this next node. And this one is the most divergent. This is the most divergent of all. Okay, so let's see what the questions are. The real tree is an additive tree. That's what I was hoping you'd realize, that since the branches are not all the same length, and they are proportional to how similar these guys are to each other, then you say, okay, this is a type of additive tree. Maybe a little bit more about, let me make it bigger, about what this means. No, how is this length shorter than this? So this means that whatever this sequence is, it's more similar to the ancestor than this one similar to the ancestor. So you could think there was an ancestor to both of these, and this one has a shorter branch, so it's closer to that node, which means that it's more closely related to the ancestor than this one. You could also think about it as there was the ancestor, and okay, mutations happen, and now we have this guy and this guy. And since this has a shorter branch, there are fewer mutations if you compared this to the ancestor than the number of mutations between this, so that, and that ancestor. So the longer branch means that it's more different from that. And I think with that, I addressed all of the questions. So the part I was just explaining that is this, that the longer branch on the 40, or the branch on the 43 is shorter than the branch of the 39. Let's see if that part is true. Let me move over here. Yeah, so the 43 one is here and the 39 is here. So that branch is shorter. Okay, that part I'm not lying. So yeah, shorter. Then that means that 43 has fewer mutations than the 39. Yeah, that's what that means. So in comparison to the ancestor. So that is true. And the last one. Okay, wait. So that one is true, not true. And the last one is saying that those two entities are equally distant. So to 442. So 442 is this guy here. So when these two branches are the same length, then that would be true. So like if that branch and that branch were the same length, then you would say this guy, that's the next one that branches off of that, would be equally distant to this and this. And in class, I told you that if we flipped these two, then that would still the same topology. So they would still be equally distant to this guy. But that is if that and that had the same length. But because they don't, then this guy is actually closer to this because the distance would be that plus that, then this and this, because that and that are a larger distance. So when I say they're equally distant, that is not true in this case. That would be true that this is equally distant to this and this if these two branches had the same length. In class, I taught you how to do the UPGMA. That's a clustering method. And when they do UPGMA, is an unweighed pair average. So basically, we just split the difference so that these branches have the same length when we do UPGMA. But then there are more refinements of clustering methods. So that's how you end up with these branches of different lengths when you have these more refined additive trees. So that was question 10. Let me try to do like